Hope you guys don't mind. Is my mic on? Can you guys hear me? I'm with the Ministry of Done. I don't do lecterns. I have to, because I used to be a teacher as well. So I'm going to come down here on the floor if that's all right with you. I'm not going to do anything weird like sit next to you or touch you or anything like that. But I need to be able to see on the screen what you guys are looking at the same time so I can point to a few things. And I guess before I start, just a bit of history about myself. When I left academia about 8 years ago to go to Cawthron, a lot of the academics at the university said, "Oh, you're going to Cawthron. You're leaving science and you're going to do monitoring." That's often what people associate with Cawthron is monitoring. And those folks in that ivory tower were right about one thing, and that was that I do a lot of monitoring. That is what Cawthron does a lot of, but I never left science. And what I want to demonstrate to you today is how so much science and technology, how it underpins monitoring and plays such an important role. And I would also argue that most scientists, if not all, no matter what field you're in, are more or less doing some form of monitoring. They're measuring things in time and space. And when I first put together this talk, I thought, well, the first thing I want to do is define the word monitor. And what sprung to my mind was actually, and I don't mean to pick on Grant Rosewarne here, but my first thought that came to mind was to pick up the phone and call someone like Grant and say the word monitor and see what comes to his mind. What is the first word that would come to that guy's mind? And I started thinking about some of the mussel growers and some of the other people in aquaculture that I work with. And so I sat there and compiled a list of what I think would probably come first to their mind, appreciating that they know that there is important attributes to monitoring. And this is the list that I came up with, and I'm not sure if Grant would agree or not. But I do think a big part of monitoring that we do in New Zealand is around compliance, is to comply. But to a lot of folks, it might seem like, oh, we're just collecting a bunch of data that goes somewhere. We produce these really overcomplicated reports and they go somewhere and most likely are inaccessible, those sorts of things. And most importantly, it seems like we're just pouring money into this vast black hole. You know what? I sympathize with that because I get that sense that we're doing that too. And so a lot of what my talk is about today is getting a paradigm shift in how we think about monitoring in New Zealand, and it's currently happening. And I'm going to show you some examples of how that's happening. So this is about getting monitoring to assist the seafood industry rather than burden it. Okay, so this is actually the list off Wikipedia, which is the easiest way to look up the meaning of a word. And this list is really what monitoring is about. And those last two is what I want you to focus on, because it's about helping you direct your industry to allow you to plan. It also enables you to watch over your industry. Now, as someone pointed out this morning, you cannot manage what you do not measure. And that's totally true when we think of anything in the business context. You would not give people money if you didn't know something about what that market's doing, what that currency's doing, and so forth. So we have things like, currency over here on the left, individual sort of portfolio stuff, and then we have things like NASDAQ or Dow Jones that tell us more globally about what's going on. It's no different in the environment. If we weren't out there, these geeky scientists measuring things like CO2 or pH and those sorts of things, we wouldn't know where the hell we sit in terms of ocean health. And we can do that for individual parameters, or we can look at it globally, like you see here on the right. Now, you guys need to pay attention to that stuff because there's one simple equation here, and that is that your seafood industry, the health of your industry is directly correlated to the health of our ocean. And you can never forget that. And I know I'm preaching to the choir here. You guys know that. So if we sort of zoom out and think about our ocean and what is actually threatening our ocean and therefore your industry, the big main players in the game are things like pollution, resource exploitation, habitat loss, and climate change, of course. And then you have biosecurity issues, mainly around things like island nations, like here in New Zealand, that's a particular issue. And then we got this thing called multiple stressors. So to complicate matters, a lot of these things can work in synergistic ways to adversely affect not only the ecosystem, but your resource. So if I now zoom in on New Zealand, that list doesn't change at all for seafood. It's the same exact list. All I've done is blown it out to give some examples more specifically as to how these things affect you guys. This is a picture from Landsat 8. It's a new satellite that goes over every 2 weeks now and gives us some great satellite imagery. This is Tasman Bay, as you know, and Golden Bay. Doesn't always get the full path. But right here, you can get a good, a picture speaks volumes in this case. So the big ones for us, obviously sedimentation, contamination, nutrient enrichment, of course, and habitat loss, for instance, seagrass, the work that they're doing up in the Kaipara Harbor, we know that a lot of your fish species spend part of their life stages in coastal environments, and they depend on things like seagrass meadows. Acidification, pests, disease, the list goes on and on. So what I'd like to do is sort of tell a story. I'm going to tell two stories today. The first one is about mussel harvesting in Tasman Bay and how monitoring can help, or the tools that we're developing can help that industry. And I'm going to be focusing on this area here, the one in pink, which is the area where they're growing primarily, well, growing green shell mussels now. Some of these are spat growing areas, and there's also some areas out here in Golden Bay where they're growing green shells as well. But certainly the things I'm talking about today would also impact things like the cockle harvesting, scallop fishery, those sorts of things. And so some of the tools, let me first tell the story is why this is such a problem for the shellfish harvesters out there. What you see, that time series is of the Motueka River. Now, to meet export requirements around seafood safety, we have to have very conservative measures in place to make sure it's a safe product. And we do have very safe products in New Zealand. We have excellent shellfish sanitation programs. What I've just highlighted there are the times that those farms are closed. They cannot harvest because the river flows are above 60 cumex. Now, you go to a wine grower or a dairy farmer and say, oh, you can't milk your cows for a few days, sorry. Or you can't go harvest your grapes this month. You're going to have to wait a month before you can do that. I don't think that would go over too well. And it's just as important for these guys, because these mussels, these green shell mussels, can lose condition in literally like 2 days. Once they spawn, they just lose all their condition, and they lose their value. If you were to fully develop that AMA area out there in Tasman Bay, that's worth a lot of money. And to be able to tighten up on these harvest restrictions means in the order of $5 million to that industry once it's fully developed. So we need to be thinking about what sorts of monitoring tools can we get in place to help that industry work around that. Because if we're not going to fix it, you got to work around it. So some of the key tools we got going, molecular one. So this is our ability to actually take a water sample or shellfish sample and tell where some fecal matter has come from, or if there's a harmful algal species around that forms HABs, those sorts of things. And the other tools that I'm going to touch on later, numerical models and instrumentation, which feed into each other and allow us to start forecasting effects or measuring things in real time to tell you what's going on in the environment. And even more exciting is the emergence of these molecular tools with our more traditionally physical tools to be able to actually measure DNA byproducts in the environment in real time. And that's an example I'm going to give you today. And so what these instruments are that I'm showing you in these photos, one's called Gordon, Neo, clearly named by geeks. These guys are from the Monterey Bay Aquarium Research Institute, and these are called environmental sample processors. The deployment I'm going to show you was where we took these instruments, which can sample the water. You can call it up on a cell phone, it'll sample it, it'll extract the DNA, it can tell you whether there's blue shell mussel spat, or if there's harmful algae in the water, or if there's fecal bacteria and where it's come from. It can tell you those things, and you start getting results within 2 hours. The deployment I'm going to show you is the first of its kind in the world, deploying an instrument like this in a mussel bed. The next journey this instrument might be is Mars. It's a candidate to go to Mars once they shrink it down to the right size. So this is really exciting stuff. So what we did was we put it into a can. You could almost fit a scientist themselves in that can if you give them a bit of food and water. And it's basically what this thing is doing. It's acting like a molecular scientist in a can. And we put it out there right by this mussel area here. It sat below this float, which telemetered the data to us over a 30-day period. In the background, you see another buoy system that is collecting the basic water quality parameters like salinity and temperature. So if I walk you through some of the data, some of the information we found, as always, weather didn't really cooperate. We ended up having to deploy this thing during a dry period. It was our only shot. So what you should be seeing is very clean water, because this is when they were actually harvesting. And so what you see here in the river flows is we had some big floods after we deployed it. What you see there, some basic surface salinity measured out there. Imagine if you weren't measuring that. You wouldn't know when that fresh water is 6 to 10 kilometers offshore. And it really tells a story there. So basically, the river's offshore during those flood events, and you really see that in that salinity measure. What did the ESP pick up? We were measuring various types of fecal bacteria. Even though it was very, very clean water, it was able to detect 1 to 2 cells in that 100 mils of water. So it was there, but it's looking for a needle in a haystack. But perfectly fine to be harvesting during those times. And this is what the water looked like out there. If you were to look from space, this is sea surface temperature. Those squares are your harvest areas. That's some cold water coming out of the inlet. So that was June 1st. So right in here, perfectly fine to be harvesting out there. Changes when it floods. This is what it looks like from space on this date here, right after that flood. All that fresh water coming out, and definitely in the area of those growing waters. And that's what it looks like on the surface. So lots of fine sediment coming out as well. Now they farm those mussels at 8 to about 20 meters deep. We collected some mussels off the farm itself, and sure enough, they are more contaminated during those flood events. Okay? We're also able to take bacteria out of the guts of those green shell mussels and run different types of source tracking markers on it. So we were able to find bacteria associated with ruminant animals such as cows in the guts of those green shell mussels. So these sorts of tools tell a very compelling story. But what I want to do is switch to a different region and show you how we're taking a real shift in how we think about monitoring. So we have a very forward-thinking council up there, Waikato Regional Council, that is rethinking how they conduct their monitoring in the region. Okay? They have jurisdiction over the first 12 nautical miles. And that map on the left shows you all the pressures occurring in the Firth of Thames and out here into the Rocky Gulf. It's not just you guys out there affecting the marine environment, it's a lot of things. And this is how we do our monitoring, okay? And we as scientists find it very hard to be able to tell a story about the wider environment when all we have available is data from individual consents. So the idea is that we get standards in place and we do monitoring in a way that is far more efficient for you guys, but then develops sort of this bigger umbrella of state of the environment monitoring that it sits within. Okay, not something that you guys would necessarily be responsible for, but something that tells a much better story about what's happening in the bigger world. So what this does is it avoids perverse incentives. That is, if we were in this scenario here, you could be impacting you would know very well what's happening at a consented sort of area or within your farm or whatever you're doing, but you wouldn't necessarily know what's going on in the wider environment. So this sort of a approach to it protects you from those perverse incentives. So sort of something that's developing around this new way of thinking about the monitoring are the types of tools that are being developed. And this is where I think there's some really exciting movements forward in the space. Things like numerical modeling, good for forecasting, merging that with the real-time data systems, which I told you about, and even things like satellite data, and pulling that all together into something that the region's calling a marine management model. So it's a model, but it's going to be capable of doing lots of different things, not just giving forecasts, but over time becoming operational and being able to give you nowcasts. So what is happening now? What might happen in the future under various scenarios? And so we've gotten it to the point where, with some of our collaborators, we got the hydrodynamics built for this model, and we've started to look at aquaculture effects. And the whole premise of this project has been around building tools that are accessible. So this council actually has this on their computer. They can run this thing, and they can share it with other councils. That same model can be taken elsewhere. It's open source code. Other experts from other agencies, institutes can come in and build it and make it better. Of course, it didn't work. So this is a movie that was working in the other room. Sure. So what you see on the left, if you can imagine, this is surface temperature on the left side, surface salinity on the right. That was over several tidal cycles. And what it allows you to do is visualize how those parameters change over time and space. Oh, there you go. Is it going? So the salinity one's going. And what's fascinating is you can also see the wetting and drying of the intertidal zone and those sorts of things. So we're moving away from sort of a consent level monitoring situation to one where we're developing tools where a wide range of stakeholders would be able to visualize what's going on in the environment. And part of this is looking also at, well, how does aquaculture fit within the scheme of things? So just as a sort of a first stage, what we've done here is we've put in farms in the Wilson Bay area and out here in the New Coromandel Marine, the area designated for finfish farming. And so this is putting in sort of simulated kingfish farms. And here, you begin to appreciate, well, I mean, this isn't exactly how it happened because there would be food web things going on. But what it tells you is, well, if you were to add nitrogen in these various locations and let it sort of accumulate over time, those are the sorts of inputs you'd be looking at those farms. This is what's coming in from the ocean. And look what's coming in off the land, an order of magnitude higher than what's happening around those farms, which sit in the footprint of that. Okay, so we need to be thinking about how your industry sits within a much wider footprint of many other things going on. And so really, what I'd like to sort of, I figured I'd put forward a challenge to you guys, which I think is actually a challenge for our country that we need to be thinking about, is how do we take that sort of a concept where you can develop these sort of better tools for visualizing what is happening now and what could be happening tomorrow, and scale that up to a national level, because we do sit on, what is it, the 4th or 5th largest exclusive economic zone in the world. Well, that is a massive space. How do we actually visualize what's happening in that space? And so this isn't a terribly new concept, but I think a good answer would be for us to be working towards what I'm calling here as an open access ocean observing system for New Zealand. Now, a lot of the things that I already talked about, like some of those buoys, that could form part of the coastal component of such a system. And we have systems in place in Hawke Bay now, Tasman Bay. There's one going in the Firth of Thames. And this isn't about Cawthron being a buoy shop. This is about just showing the example of how you could do it and getting other systems built on the same recipe out there. We could have ports offering up their data, research stations like Lee, Otago. They have great data sets that could be feeding into this. And as long as we're following standards and protocols, that could be a shared resource and go in towards these regional programs. Well, then we can start thinking bigger, the wider EEZ, all right? Lots happening in that space as well. NIWA has launched more Argo drifters than any other institute in the world. Now, there's been 1 million of these deployed throughout the world's oceans, and what these things do is they float around and they kind of do these profiles and tell you what's happening in the water column. So basically, we're out there doing it. We have lots of different data sets already currently available. We also have some important partnerships through NIWA and other governments, CSIRO, NOAA, those sorts of organizations. And so the idea is that if we could pull in these sorts of data from ocean type of scale stuff, even ships of opportunity, so that would include you guys, and actually develop a collaborative governance around how you could be pulling that information together. We already have some of this happening. We already have some of the sort of portals that exist. The idea is that then you have all those data that you could be using to develop those nowcasting systems. So in 2 years' time, you can hold me to it. I bet when you're out in your boat, you'll be able to pull out an iPad, look at it, and be able to see something very similar to MetView, but it's telling you something about the ocean. It's telling you about where is that river plume. So that mussel farmer in Tasman Bay will know, well, the river plume hasn't gone into my growing area today. So they'll have far better information than they have today. So where would this stuff go? Clearly to end users such as yourself, but also, most importantly, to civic society. So much about what you guys do is about getting a better social appreciation for what you're doing. And the best way to do that is to reduce uncertainty, get rid of imagination, those sorts of things, and actually help the public visualize what is actually happening out there. And of course, it would also enable New Zealand to plug into the grid, because currently, I would consider that we're off the grid. Now, is this needed? I would argue that it is. Imagine if you didn't have this sort of data or information coming in, how difficult it will be to plan accordingly. Is it expensive? Absolutely. Hugely expensive. However, if you pull other people in other than just aquaculture and fishers or seafood companies and those sorts of things, I mean, perhaps Dairy NZ should be contributing to this. I'm not sure if he's still in the room. I forget who is here. But other companies, shipping companies, regional councils, central government, and all sorts of different sources of money. Recreational fishers, perhaps. So my last question is it achievable? And I thought I'd throw up this photograph of my colleague, Paul Barter, and explain that all those systems you saw out there, that guy built in this little shed. That's his room right there. That's how big it is. He calls it, he loves Dr. Evil, so he calls it the Elasmobranch Cranial Laser Research and Development Lab. So he's a bit of a geek. But the good story in this is that one guy with an institute behind him and some very good friends from overseas that have heaps of money and heaps of toys that are falling off a truck, literally, and happy to share them with us, is that if we partner with the right organizations, we pull everyone into the tent, we can actually achieve it. And that's it. Thank you very much for your time.